Hey everybody, welcome to notes number 16. We have spent the last several lessons dealing with algebraic expressions and equations. And in this lesson, we're going to take that and connect it back in for solving in some real world applications. So the first thing to do is to recap. Remember, I'm an expression if there is no equal sign. This is where you cannot undo anything. If all you have is an expression, so for example, if I had done 3t plus 2t, 3x plus 2x is 6, the only thing I could do is combine these by adding those like terms. When we have an expression, we follow PEMDAS, and I use what they give me. I don't undo or change anything. An equation is where I have to have an equal sign. It is only in this step that I can undo my numbers in order to solve for x. Remember, we always do that in reverse. I do addition, subtraction, then multiplication, division, then exponents in parentheses. So here I would subtract the 6 first, then I would divide by 3. It is only legal to do that in an equation where I have an equal sign. So with that recap, let's see what we can do to translate words, real world problems, into the math symbols that I can solve for. Now, some of this we've done before back in our first round of lessons. Remember, addition is words like plus, sum, more than. Subtraction, minus, subtracted from, less than. Remember that more than, less than, anything with the word from, all require me to switch the order of my numbers. Multiplication is things like multiplied, times, product, twice. Division is divided, ratio, quotient is a big one. And now we're bringing in that equal sign, which takes the words equals, is, or is the same as. So the first thing we're going to do is use some words and translate that into my algebra. Anytime they say a number, I'm going to use x as my placeholder. So the quotient tells me I'm going to divide a number. I'm going to use x and 12. That is telling me take the first thing, x, and divide it by the second thing, 12. You can write it side by side, or you can stack it in a fraction. This is called an expression because I never had an equal sign. A number, anywhere they say a number, I'm going to use an x placeholder. Increased by tells me I need to add 11. Again, this is an expression. Nowhere in you have brought in an equal sign yet. Try the next two. Pause and try the next two. The next one says I have 3/4 of is part of my multiplication list. That tells me to multiply by. A number is where I put my x placeholder. So I have 3/4 x. Next I have 13. Decreased by is in the subtraction list. A number is x. Okay, we're getting this. Let's do a couple more. This is where we might start including an equal sign. So go ahead and also tell me if it's an expression or an equation when you get done. 9 is. Wherever they say the word is where I'm going to place my equal sign. So 9 is becomes 9 equals. 5 less than tells me to subtract. A number is where I put X. But remember that less than really tells me I need to switch this order. So I'm going to switch the 5 and the X. 9 equals X minus 5. And this is our first equation. Next up, 10 less than tells me to subtract a number. Nowhere in there did I see an equal sign pop up, so this is an expression. One more, just practicing our setup. 4 times a number. 4 times tells me to multiply. A number is X. Is the same as is my equal sign. Then I have 6. More than tells me to add. Twice tells me to multiply a number is X. But remember that more than is one of those that I switch the order on. So 6 and 2x need to switch orders, giving me a final answer of 4x equals, switch them, 2x plus 6. Anytime we have these equations, I could take it a step further and solve if they ask me to. Now that we've practiced this setup, we're going to use it in the context of our word problems. So number 8. If 3 times a number is subtracted from 8, the result is the difference between twice the number and 7. Find the number. Well, the first thing we want to do is get those words into our math. So it says 3 times a number. 3 times x is subtracted from 8. But remember that subtracted from is one of those that I need to stop and switch this order before I continue. So I need to switch this as 8 minus 3x. Now the result is where we place our equal sign. And it says the difference between. So difference means I'm going to subtract, but they haven't told me the two things yet. The difference between twice the number. Twice means 2 times our placeholder. That goes first. And is where I have my subtraction sign. 7. So I end up with an equation from my word problem. 8 minus 3x equals 2x minus 7. And that is what I solve for x. Now remember, when we're solving, that's when I follow the undo process. Now, how you undo is kind of up to you in this step. But what I see is if I'm focusing with my x's, I've got them on 2 different sides of the equal sign. And I don't really like the fact that one of them's negative. So I'm going to undo a minus 3x by adding 3x to the other side. That leaves me 8 equals 2 plus 3 is 5x minus 7. Now, I've got x in a single spot. That's wonderful. But this minus 7 is tagging along. So let's undo it by adding 7 to the other side. 8 plus 7 is 15. That equals 5x. Last but not least, in order to break the 5 away from the x, I'll divide it to the other side. 15 divided by 5 is 3 equals x. So my unknown number is 3. 2 more to go for this video. John is 6 inches taller than twice his daughter's height. If John is 78 inches tall, how tall is his daughter? So just like we've done before, the first thing we want to do is take this sentence and translate it down into the equation. When you have real world problems, use a real letter placeholder. So John is, let's use J for John. Is equals. So John equals 6 inches, so 6. Taller than is the same thing as more than. Twice his daughter's height. So 6 more than means add. Twice means I have 2 being multiplied by whatever comes next. Twice his daughter is where I'm going to put a second letter, D, placeholder for that daughter. Now remember that more than means I need to switch. So rather than 6 plus 2D, this should have been John equals 2D plus 6. And we set up our equation. Now the problem here is that I've got 2 letters. I have 2 placeholders. Thankfully, they tell me that John is 78 inches tall. So John can be replaced with 78 equals 2D plus 6. And now I am set to solve. In order to get the daughter by herself, first thing I'm going to do is subtract 6 to the other side, giving me 72 equals 2D. Now I divide that 2 to break it away. And that daughter is the same thing as 72 divided by 2. If you don't know what that is, have yourself a side conversation. 2 goes into 7 3 times, using up 6 in the process. 7 minus 6 is 1. Bring down your next number. 2 goes into 12 6 times, using all 12 in the process. So the daughter is 36 inches tall. If you didn't know, that's the same as 3 feet. All right, let's do one more before we stop this video and shift gears just a little bit. So an Uber driver charges a base rate of $6 along with 25 cents per mile. A Lyft driver charges a base rate of $4.50 along with 40 cents per mile driven. For what number of miles will the charges be the same? All right, first thing we're going to do, take one sentence at a time. Uber charges $6 along with 25 cents per mile. Let's use U for Uber. Uber equals a particular charge. $6 along with is where we're going to add 25 cents per mile. 25 cents is the same thing as a decimal 25. And because that's related or based on the miles driven, I'm going to connect it to the letter M for miles. Now I have a new sentence. Lyft charges a base rate of $4.50 with 40 cents per mile. Following that same process, Lyft charges or equals $4.50 along with 40 cents per mile. So 40 cents is 0.40, and I'm going to connect it to my mileage. Now they have to tell me something else because right now I've got a lot of letters going on. It says, for what number of miles will the charges be the same? Same means I want Uber to equal Lyft. So I'm going to take my Uber formula and my Lyft formula and set them equal. 450 plus 40M is going to equal 6 plus 0.25M. Yes, I have decimals going on, but the process isn't changing. Starting off with my miles, I need to get them on the same side. So let's subtract our smaller, our 0.25M, subtract our 0.25M to the other side, leaving me with 450. 40 minus 25 would be 15, but remember it's a decimal. So I have 0.40 minus 0.25. Borrow. 10 minus 5 is 5. 3 minus 2 is 1. And keep your decimal in the same spot. Now that M is in a single spot, I'm going to subtract 450 to the other side, leaving me with 0.15M equals, borrow, 0, 5, 1. And divide by 0.15 on the other side. Having to play with those decimals a little bit. So if you don't remember those or you have questions on it, make sure you reach out. When dividing decimals, I don't want to keep them. So if I move this one 2 spots to the right to make it 15, I also move this one 2 spots to the right to make it 150. Then I can divide 150 divided by 15 is 10 miles. Whew. All right, I know this video has gotten a little bit long, but we're setting up our equations out of the words. Then we're just solving our equations as we are used to. If you have questions on these, as always, reach out. This is a great conversation to take to tutoring for this week's tutoring requirement. In the next video, we're going to come in and see how these words connect to percentages.